Hi, this is Andy from MBS Tech. Today we're going to learn how to create a library in Altium. Um, Altium Designer is the tool of choice for me, and I thought it might be nice, relevant to show you how and why I create my libraries the way I do. So let's get into it. So what we first need to do is we need to do a new library. So we'll create a new library. It's going to be an integrated library, and we'll hit create. It's going to be a file-based one. So we're going to save this. I'm going to save it down here, and we'll save it. Let's put a new folder. We'll make resistors today. Okay. So what we'll do, we'll save this as a TNPW. TNPW. Okay, great. Okay. The TNPWs are a type of resistor which I tend to use. They are 0.1%. We can get them in different percentages, but I generally use them for precision work. 0.1%, 10 or 25 ppm you can get. So what we need to add to this project, of course, is a schematic library, and that's what we need. That's brilliant. So I've got this. Let's just minimize this a bit. And the first thing we need to do is I suppose draw a schematic symbol. So for the purposes of speeding up this recording, I've drawn the symbol, but just to quickly show you how easy it would be to do, we can just, let's change our grids, because that's not what we want. G, oh, that's better. So we can start here, and we can go up, down. As you can see, it's quite easy to do. When we change this now, we can change it to change the color to blue. As you can see, that pretty much overlays that. And then all we need to do is add some pins. These are quite cut down pins, so 100 length on that. They're passive. 1 1. We don't really want to see them, to be fair, unless you do, and then of course you do. So just plot this up there. Now you see here there's this little like dot there. That's what you connect to. So what you want to do is make sure that's on the outside. We can now copy this. Control C, Control V. We can put that on the other side, and we can change that to, that's our 1. Brilliant. And now we can make this our 2. And that's how easy it would have been to create this symbol, so it's no big hardship. We're going to save the library as a TNPW. And now what we need to do, this is a generic symbol, and what I tend to do is I create a new entry for each part. So we're going to go off and we're going to find a value of resistor, can be anything, and we'll start feeding those parts in. So let's go to Mouser. Let's make something nice and easy. So let's pick a 1K resistor. 1K. We'll make it quite high tolerance, so 0603. That's what we're going to be doing at the moment. And here we've got these two parts. So what we'll do is, actually, let's pick a slightly better tolerance, because the other tolerance bands are typically, there's more of them. Okay, So we'll copy that. We'll copy this information. So we'll make a 1K resistor. So this is the part number, manufacturer's part number. So copy that and go to schematic library down the bottom, edit, and bring up the properties dialog box. The component ID would be, in my case, the part number. Now the designator would be our question mark. The question mark gets filled in by the annotation process. Now some people tend to put the part number as comment, but what you can do is you can say it's a 1K, it's an 0603. You need to put something, I would say, because this will be visible. I don't normally, this part number is not normally visible. That's normally something that you pick. What you see on the schematic is what I'm putting in now. So the 1K 0603, call it what it is. It's a TMPW type resistor. Yeah. 0.1%. And you could put 25 ppm and all that sort of stuff in there if you wanted to. But I would tend to keep it quite short because it'll fill your schematic up quite quick if you don't do that. Other information, description, we'll copy that. That's free. Let's put that in there. Okay, so that's the general information that we need for this resistor. Now, there are a few fields that I would add. And this is personal preference, but this is what I have found that is the smallest list that gives you the right pertinent information to be able to sustain your libraries. So the first thing we want to add is a parameter, and what we want to call it is manufacturer, that's it. In this instance it's Vichy. Okay, that's that. We add another parameter, and this parameter will be manufacturer's part number. Okay, and we'll copy this and we'll put that in there, and we'll add another parameter, and the other parameter is, I'm going to say it's called life cycle, and I'm going to say that this is active. Now the reason I put life cycle in there is because sometimes you might create libraries and you don't want to keep on removing them, because if you remove them and you manipulate some other project later on, then it's not in that. So, but if it does then get flagged up for not recommended for new designs, then in here you can go not recommended for new designs in your library field. That way, when you come to place a part again and you find this part, you go, oh okay, it's not recommended for new designs. Okay, I'll build another one that is active, or I'll find something else in my libraries. So that's what I add that there for. The other thing is a link, and I'll call it datasheet. Now it's a bit, I suppose you don't really need this because what I'm going to show you next actually gives you the datasheet, but there are certain rules of thought. Sometimes when you design something, it's good to capture the datasheet of the part that you're using at that current time, so that current version, because datasheets do change. So sometimes if you add a automatic parameter, which I'm going to add in a bit, the datasheet will get updated, and some pertinent information might get changed, of which you've designed to, say on version 0, it's now not there on version 1. So this field here could point to your database, so your local copy, your historic copy, or it could point to a version online. So it could be anything, but this is a manual datasheet variable, which I would encourage you to use, because then you get control of whatever datasheet you're actually using as part of this, and I'll show you how to easily add this now. So what you got to do if you want to just do it, so if you just want to do it straight off the website, you can just right click and do copy link, and paste that in there. Right, so you see it's not actually giving me anything datasheet, so I would recommend you click on it and make sure it takes you where you think it should go. Okay, so in this instance it has brought up the TMPW E3 series, which is what we're using, and it gives the right datasheet. Right, so this could quite easily be somewhere on your network drive, for instance, but for the simplicity of this demo, I'm going to just use that. Now, the next one is down here, edit supplier links. So you can click on this, and if you've got your supplier links set up, and by default Altium does, but you can actually streamline them and manipulate them, remove certain suppliers off depending on how you want. You can add what we call a supplier's link. Now it's going to go off and it's going to go, oh, I can't find anything there. Oh, it hasn't, it's found it. Okay, so what I would suggest you do is, first of all, you can copy this part number, copy that, edit suppliers link, add one, stick it in there. Okay, and then you see that the field's changed. It was 2 before, now it's 15, and I'm getting my bits from Moser, so that's the part I would choose and go okay. Okay, now the thing down here, see, it automatically gives you a datasheet link. Ooh, brilliant. Okay, but that's slightly different to that one, if you've noticed. Yeah, so you have to be careful, like I say, of which datasheet you use, which is why I always pick the manual one. Okay, but the other one there is sort of a backup, and you get it for free anyway. Okay, so these columns here, these parameters here, when you generate a bill of materials, you can pick these columns, so you can get a nice parametric view of your BOM, what manufacturer part number, whether it's active or whatever. It's very good. And there's also a thing called ActiBOM, which is another, like a live BOM generator, which I won't cover in this video, but that's also pretty good. Right, so this is the minimum amount of information I would recommend anybody to use for generating a part. Okay, so now the only thing we need to add now is a footprint. You can add, if you're going to do simulation. I don't use Altium for simulation, I just use it for PCB design. So I'm just going to add a footprint, for instance. So I'm going to save this. Okay, now in my schematic library now, if it's got a part. If I want to add another part, it's quite easy just to copy, paste, and then manipulate it. So you don't have to recreate everything, and I wouldn't do so. So for the schematic point, this is all we need to do, other than add a footprint, of which now I'm going to take you through. Okay, so what are we on? 13 minutes, so we should be able to do the whole part within half an hour, I would have thought. Okay, so we go back to projects and let's save this. Now we're going to add new to project a PCB library. Now you can have one PCB library and many schematic libraries, but I tend to keep mine separate. So first of all, like everything, I'm going to do a save as, and I'm going to save this as a TMPW PCB list. Okay. Now, what we need to do is we go to our PCB library, and it automatically gives you one component by default. And if you want to generate that, if you want to delete that, you have to add one first. You can't have an empty database. So an easy way of doing components is an IPC compliant footprint wizard. So we'll click on that, and this will take you through the process of generating a compliant footprint. Now let's find out what we want. It is, oh look, component chip. That's exactly what we want, so we'll click on that, and then we're going to need to fill in these bits of information. So let's have a look. So L, body length. Okay, so let's have a look at our data sheet. We're going to use an 0603. Let's scroll down to the bottom where the data sheet information is. Okay, so here L. So 0.605. Yeah. So 0.6 plus or minus 0.05. Okay. So the minimum is going to be 0.6. So 0.595, and the maximum is going to 0.605. That's our maximum. I'm going to get the plastic brain out at the moment and make sure that those things are correct. 0.6 plus 0.05. There we go. 0.5. Was it 0.5? Let's have a look. Yeah. So 0.65 and 0.6 minus 0.05. 0.55. See, messed up straight away. Brilliant. Okay, width. Our width is 0.3. Sorry. See, nobody's told me I got the wrong value. So actually our value is 1.55. Yeah. Okay, so 1.6 and 1.5. Okay, better. Yeah, you got to be careful with these data sheets when you're in wrong. 0.85. So 0.85 plus, and what was it? 0.1. 0.1. 0.85 plus 0.1. 0.95. Yeah. 0.95. 0.75. Okay. What else we got? We need a T. T. Okay. T is our termination. So T. We got a TA and we got a TB. So TB is the one we're going to be sold into. So our TB is 0.3. Where are we down here? So it's 0.32. And 0.28. Is that correct? Probably not. I think it was 3, wasn't it? No, it's 0.3. Yeah, that's right. Okay. Now our height. Our height is 0.45, and we're just going to give it a. We're going to tell that it's a resistor. Okay. We can click on here, generate the 3D model automatically, and we click on next. We're going to use the calculated values through this, and you can have a read and change those if you want to. The silk screen, I always put slightly lower silk screen, and we'll click finish. Okay, so here is our resistor. With 3, we get a 3D view of it. Now, I tend to like my pads slightly rounded. So rounded rectangle, and there we go. That's how I prefer mine. So here is our 3D our footprint for all intents and purposes. I actually don't like the model. Some people do that it comes with. You can't really pick your color. But we'll go back to our projects now. We'll go back to our schematic. Now we can add a footprint. Just make sure you click on library now, because sometimes you can have mixed libraries. Click on that. Okay. Brilliant. We got it. Critical thing, make sure you got pin 1, 2, which is very good. And make sure in your footprints you got pin 1 and pin 2. Okay. Now, if we right now click and go compile, it'll ask us to save. It should do. And then it's save. Yeah. So now we will have a part to place. If I go up to my components here, look for our TMP integrated library, you can see now we have one place. We can place that now. If we had a schematic open, we'd be able to place it. Okay. What I'm going to show you now is a way of manipulating the 3D footprint of this part. So I'll bring you back in a bit, and then I'll take you through. Okay, so we're back. Right, so we've got this footprint here, and it's got a 3D view of that. Okay, and it's not a bad model by any means, but what I tend to do is, because I want to know where the important resistors are, and generally the precision ones are the most important ones from a resistor point of view, else they wouldn't be precision. So I tend to colour mine a slightly different colour rather than the default black. Okay, so you can add your own model to this. So what I'm going to do, I'm going to take you through how to get your model. Now, you can go to many 3D model sites, but I tend to use 3D Content Central a lot of the time, or GrabCAD. So here I've got a Vishay TMPW0603. I'm going to click on this, and I'm going to download it as a step model. So we don't want it zipped. We want to go all the way down, select a step, and it's going to configure the drawing for us, and then it's going to give us that. And that's going to go onto my downloads. So we'll just close that. Okay, so what I'm going to do is I'm going to go back to 2D mode. By the way, while I'm in Altium, if you want to go from 3D to 2D, 3, press 3, 2, press 2, and that's all you do. So we can place a 3D body here, and I'm going to browse to where I've put it. I'm going to open it, and it'll give me this. So if I press now 3, you'll see that this is a slightly different model. So we need to rotate this. So I think maybe that would do it. Yeah. Yep. That's correct. So you see how that's different. But a good thing is we've not done too bad with our model selection, because it actually sort of fits the right thing. Okay, so we're going to delete this model, and we're going to just move this across here. We can go back to 2, change my grid down to something, and then I'm going to place it in the middle. Okay, so if I press 3 now, you'll see that that's my, but it's still black, which is not great. Okay, but I'm going to save this anyway. So what I'm going to do is I'm going to go to Fusion 360. Okay, and I'm going to open the step model. It's going to bring it in. we can use our orbit command here, and I'm going to click on this, and I'm going to go appearance. I'm going to change colour. So there's many colours we can choose. So let's change the colour of it. Plastic. No. What are those? Paint. Glossy. Blue. Blue's nice. Yeah, that's a nice colour. And then we can now export that, and we'll call this blue. Okay, and we're going to export it as a step file, and we're going to export it there, and we're going to export. So it says now it's ready. Okay, we're just going to minimize this. Okay, now instead of replacing this, I'm just going to click on it, go to properties, and I can choose my model down here now, and I'm just say blue. Now hopefully, if I've done my job right, we should have a... No, it hasn't done it. Why? Let's do that again. Appearance. Blue. Now we should do it. I didn't pull it across, did I? That's me being silly. I'll export. Export it to blue. Save. Yes. Export. Yes. Okay. Now let's try it again. Let's choose again. Blue. There we go. We got a blue resistor now. Brilliant. Hit save. Now, what does this mean? Well, you got a blue resistor. Brilliant. You might say. But what it does mean is anytime we replace this part on the board, it will show up as blue. Now, what you could do is you could say all my blue resistors are 25 ppm. All my green ones are 10 ppm. It gives you then, when you're looking from a 3D point of view, it gives you more information. It shows you where things are. Okay, so I hope that this was informative as usual. I hope you've got something from this. How long are we? Well, we've got a few more minutes. I'm trying to keep it to half an hour really. So what we'll do is we'll go to schematic library. More quickly, I'll show you to just copy and make a 10K. Paste. Then we've got this value here. We'll click edit. Exactly the same information. We'll come up to Moser. And we'll search for a 10K. We'll click off this. And we'll search for 10K. At least then I can show you that it's very easy to just copy and paste things around. 10K, click apply. Click on that one. And then we can copy this part number. Oops. Control C. Go to our Altium. 10K. We can change this manually. 10K. We'll change this manually. 10K. Change that. It's going to have the same data sheets, the same series. I'm going to edit the supply link. We're going to delete this one. And then we're going to add a new one because it's obviously a new part. And then we'll click on that one. OK. Click OK on that one. Hit save. And that should be everything. No. Why isn't this? Oh, okay. It's just a delayed thing. We'll compile this. We'll save all new sources. Okay. I'm just going to close this project. I think there might be a slight bug in Altium, and I'll reopen it because it didn't update the yeah, see, down here now, they're all blue. So if we get schematic library, we know we've got two, and they're both blue. Okay, so I've compiled that. Close that project. So now we have two resistors in our library, a 10K and a 1K. It's very quick to recreate that 10K. You can just go down the list as and when you do it. So yeah, okay, that was just how to do a quick resistor. I'll probably do another one. Maybe an ADC or something, and show you how to do that sort of modeling and that sort of library creation as well. Okay, all right, cheers.